Hi everyone! I'm Comet Christina and welcome to Freaky Physics. Today we're doing Lesson 3, Tall Towers. You're going to need your Tall Towers kit, and then from home you're also going to need some paper towels, some water, a pair of scissors, a pencil, and a ruler or a yardstick. And I actually didn't have either of those things, so I'm using measuring tape. So anything that measures is good to go. Also, because we're using water today, it might be a good idea to put down something to cover your table just in case there's any spills. We're also going to be doing one other activity that I'm going to be demonstrating for you. So you can either just watch, or if you want to try that one from home, you'll need to gather these materials as well. You'll need 2 glasses. They don't have to be glass like mine. They can be any kind of cups as long as they are the same size and height. Then you're going to need 2 pieces of copy paper. If you don't have copy paper, that's okay. You can use any kind of other paper that's similar in thickness. It doesn't have to be plain white copy paper. And then also a cell phone. And if you don't have a cell phone, just find something that's kind of similar in size and weight. Okay, so go ahead and collect your materials and then we can get started. Okay, so today we are going to be engineers. And engineers are people who design and build things. There are all kinds of engineers. There are kinds of engineers that build things like computers, who do things like work on electricity, who work on machines. But today we're going to be civil engineers. And civil engineers design and build things like roads, bridges, and buildings, such as skyscrapers. So what is a skyscraper? A skyscraper is basically a really tall building that has an internal frame made of really strong materials like iron and steel that help the building maintain its structure. The point of a skyscraper is you want to build up so you can maximize floor space instead of space on the ground. So rather than having a really wide, long building, you can have a really tall building and still have as much square space or floor area. And this is helpful in think of like big cities, like New York City. They have a lot of population, but not a lot of actual ground to work with. So by building tall towers and skyscrapers, they are able to still have a space for people to work and live. Now let's learn a little bit about the history of skyscrapers. The very first skyscraper was designed by someone named William LeBaron Jenney and was built in 1885 in Chicago, Illinois. This was the Home Insurance Company building, and it stood at 138 feet tall. This was the first tall building to have a steel skeleton made up of vertical columns and horizontal beams. This is important because having both vertical columns and horizontal beams allows buildings to distribute weight evenly. Some buildings also have diagonal beams for extra structural support. So typically, steel is reinforced concrete beams, and it's also used because concrete is very strong and resists compression. Wire mesh or steel bars are put inside the concrete to increase its strength. So now that this building was designed, cities were racing to see who could also build really tall buildings, and the sky was the limit. So as of 2020, here are the 5 tallest buildings in the world. Number 5 is Lotte World Tower in Seoul, South Korea, standing at 1,821 feet. The 4th tallest is the Ping An Finance Center in Sichuan, China, standing at 1,965 feet. Number 3 is the Makkah Royal Clock Tower in Mecca, Saudi Arabia, and this building is 1,972 feet tall. The 2nd tallest is the Shanghai Tower in Shanghai, China, standing at 2,073 feet. Fun fact, so the Shanghai Tower also has the fastest elevator in the world. This elevator moves at a speed of 67 feet per second. To put that in perspective, a normal 2-story building is about only 30 feet tall. So to move 67 feet up in the air per second is really fast. And the tallest building in the world is the Burj Khalifa in Dubai. This building is 2,716.5 feet tall. So what do skyscrapers need in order to stand? We already know that skyscrapers are made of really strong materials like iron, steel, and concrete. But really, those materials are very heavy. So engineers have to come up with the perfect mix between strength and weight. There are a lot of forces working against a skyscraper, so engineers have to design something that can withstand all of those forces. The first one is compression. So compression would be a pushing force. The other is tension, so that would be a pulling force. So as you are continuing to build the building up and you have all this weight, it can pull down on the structure. So different examples of compression and tension would be not only the weight of the materials, but you also have people in the building, you have furniture, you have the roof, you even have gravity. And then when we're talking about really tall buildings, so skyscrapers, we also have to deal with torsion. So torsion would be a twisting force. And usually with skyscrapers, this is caused by strong winds, because when you go higher up in the air, the winds are a little bit stronger and faster. So the higher you build a tower, the stronger the winds, the stronger the building has to be to deal with torsion. So how exactly does a skyscraper keep from falling over then? So in your mind, think of how tall a tree stands. There are some really tall trees, but underneath the ground, they have these deep and wide root systems to help keep it planted. Skyscrapers are actually built the same way. So they build a really deep, solid foundation under the ground. To give you an example, the Petronas Tower in Malaysia is 1,483 feet tall, but under the ground it has a foundation that goes 400 feet deep down into the earth. For our first activity, we're going to build all the different shapes that they use when they build a skyscraper. So from your tall towers kit, you're going to need your paper plate, you're going to need 8 gumdrops, and you're going to need 9 toothpicks. So important note, I know the gumdrops look and smell really yummy, but we're not going to eat them. They have been packed by people in our warehouse, maybe even using their hands, so they're not really safe to eat. Okay, so go ahead and collect your materials and then we can get started. Okay, so the first shape we're going to build is going to be a 3D rectangle. So a rectangle is kind of like a square, but it's longer on one of the sides than the other. So grab 4 of your toothpicks and break these in half. It doesn't have to be perfectly even, we just need to make it pretty close to each other, okay? These are going to be used on our shorter side because, like we said, rectangles are a little bit longer on one end than the other. Okay, so now we can start to assemble our 3D rectangle. So we're going to use our gumdrops to stick our toothpicks into. So we're going to build the short side first. So just start assembling and build a lot of little squares. So you're going to stick the toothpick right into the gumdrops. I'll show you when I am done what my first square looks like. We are using the short toothpick pieces right now, the ones that we broke in half. Okay, and sometimes it does take a little work because some things fall over, but this structure, even though it's kind of flimsy right now, is going to get more sturdy as we continue to build. So this is my square using all the short pieces and my 4 gumdrops. So now it's kind of sturdy. You can kind of twist it. It does move a little bit. Let's build a second square just like this one. So I'm going to need my other 4 gumdrops, and I'm going to build using my shorter broken in half toothpicks. The same way as the first one, I'm going to build a square. All right, so now that I have my 2 squares, it's time to put them together to make our 3D rectangle. We're going to do this using our longer toothpicks. So now we're going to take our 2 squares, we're going to stand them up kind of facing each other like this. Nope, they're falling over. And I'm going to take a long toothpick and I'm going to stick it into one of the gumdrops at the bottom, and then I'm going to stick it to the bottom of my other square as well. And then I'm going to do the same thing on the other side. Don't worry, I'm going to show you what this looks like when I'm done so you can see what I just did. Okay, so now I have my 2 toothpicks on the bottom, just like this. And then I'm going to do the same thing on the top to build my rectangle. So right now, before I have these ones on the top, it's not very sturdy, but I'm hoping that once we put it all together, it's going to be sturdy. Okay, so here's my rectangle. Can you guys see that? So I have my long toothpicks that are not broken here in the middle to make my rectangle, and then I have my short ones to make my squares. So now it's a 3D rectangle. So now, can we kind of move it around? Is it very sturdy? I think it's pretty sturdy. But we talked about in skyscrapers, they use a combination of horizontal and vertical, and then sometimes they even use diagonal beams to really reinforce something. So we're going to take one of our long toothpicks and you're going to put it horizontally into your 3D rectangle. I'm going to show you how. So you're going to put one pointy end in one of your bottom gumdrops, and then you're going to put the other pointy end at the top of the gumdrop on the opposite side. So I'm going to show you what that looks like. Okay, so here you can see I have a gumdrop there, kind of in the middle, going from the bottom here to the top on the other side. So now, if I try to move my structure around, it is sturdier than it was without that diagonal beam. Pretty cool, huh? So when civil engineers are building skyscrapers, they use primarily 3 shapes in their building. They use arches, rectangles, and triangles. So we just built a rectangle, and when we added this middle brace, do you notice that maybe we also kind of built a triangle? It does kind of look like a triangle. So we used a triangle shape to reinforce our rectangle. So now we're going to build a triangle to see if that is stronger than just our rectangle is. So now you're going to need 6 more toothpicks, your paper plate, and then 4 gumdrops. So grab your materials and we can get started on building our triangle. So civil engineers primarily use 3 different shapes when they're building skyscrapers. They use arches, rectangles, and triangles. So when we put together our rectangles structure here, when we added that horizontal beam, does it kind of look like now we started to integrate a triangle shape to our rectangle? We did, and that triangle kind of helped reinforce our rectangle. So engineers are using a combination of different shapes when they are building skyscrapers. So now we're going to build our triangle. So take 3 of your gumdrops. You want to make sure that they have the flat side sitting against the paper plate so that it could sit nice and neat on a flat surface. We're going to take one of our toothpicks and we're going to connect 2 of the gumdrops in a straight line just like this. So triangles have 3 sides. So we are going to connect all 3 of our gumdrops on the 3 sides. So I'm going to show you, I'm putting these together. Now it kind of looks like this. So now we need to close off our 3rd side and put another toothpick there on the bottom. Okay, so now I have a triangle. And if I push down on the top, my triangle does feel pretty sturdy. So we made our rectangle 3D. I'd like us to make our triangle 3D as well. So we're going to do that by laying this triangle down on our paper plate. We're going to take our 4th gumdrop and we're going to put these all together on 3 sides and make a 3D triangle. So I'm going to stick one end of another toothpick into one of the bottom gumdrops and then into the side of the top one, kind of like this. So it's kind of floating on top, if you can see that. All right, but I want to do that on all 3 sides. So I'm going to take the other gumdrop at the bottom. I'm going to stick a toothpick in. I'm going to stick that into my top toothpick. And then we have our 3rd gumdrop at the bottom. So I'm going to do the same thing with that. I'm going to show you what this looks like when I'm done so that you can build a similar shape. So now it looks like, whoops, there we go. Looks like this. So we have this really cool 3D triangle. I've got 3 sides on the bottom. I've got 3 sides at the top, and then if you push on the top, it is a really sturdy structure. So we are going to see if triangles really are the strongest structure. So from here, I definitely think my triangle is stronger than the rectangle that I built, even once I added that horizontal beam. But we're going to experiment with that a little bit more. Okay, so now it's time to do our demonstration activity to see how strong triangles really are as a structure for building. So like I said, you can do this one from home. Most of these materials are easy to find, but I'm just going to demonstrate it for you for now. So I have my 2 cups, I have my pieces of copy paper, and I have my foam. So you want to set the cups about 6 inches apart, and I'm going to set my piece of paper on top of my cups to make a structure. So next, I want to see what's going to happen if I set my foam here in the middle on top of the piece of paper. Do you think the paper is strong enough to hold my foam? Let's find out. Definitely not. Okay, so now with my second piece of copy paper, I have made an accordion shape. So I folded the piece of paper in horizontal in like an accordion fan shape. Okay, so if you look at the edge of this, that accordion is made of a lot of little triangle shapes. So in theory, our hope is that this can make our paper a little bit stronger. So I'm going to set this long ways on my cup the same way I did the other piece of paper. And now I'd like to see if the piece of paper is now strong enough to hold my foam. What do you think is going to happen? Let's find out. There you go. So now, using the triangles as part of the structure of the paper, we have now made the paper much stronger and it holds up my phone really easily. Pretty cool, huh? Now we're going to build our own fuzzy tower. From your kit, you're going to need your 20 pipe cleaners and your 1 ounce cup. And then from home, you're going to need a pair of scissors, your pencil, a ruler, yardstick, or in my case, my measuring tape, some water, some paper towels, and something to cover your table in case there are any messes. Go ahead and collect your materials so we can get started. All right, now that we have all of our materials, we can get started. So your objective is to build as tall of a tower as possible using just your pipe cleaners. So you do have the pair of scissors, so if you want to cut your pipe cleaners into smaller sizes, you can. Just know that once you cut them, you kind of can't go back. These are all the pipe cleaners you have. Now as an extra challenge, this is why we have the paper towels and the table covering, you can build your design so that you can try to set your 1 ounce cup on the top and fill it with water and see if it holds. You're also going to need your pencil for your lab sheet to make notes. You can draw a sketch of your plan for your design or a sketch of your final design once it's done. And then you can use your ruler or yardstick, or in my case, measuring tape, to measure just how tall your tower is. So let's see how tall of a tower we can build. Go ahead and get started. Okay guys, are you finished building your fuzzy tower? How did yours turn out? As you can see, mine does not look very structurally sound, so I do not think a career as a civil engineer is meant for me. I thought my idea was good. I tried to use a combination of rectangles and counterbalancing and even doing some things across to try to make it more stable, used a combination of triangles. It still is definitely leaning. But just to see, I want to see how tall mine is. At the tallest point, mine looks to be about 15.5 inches. How tall did yours get? So I have my cup, and I did build a little loop up here to put it in, but I'm pretty sure the second I add the cup, mine's gonna fall over. I do not think that mine is built to withstand any additional compression, but we're gonna try and see what happens. Okay, so my cup fits in there, but yeah, it falls right over. So I definitely can't add water to mine, but if yours is more stable than mine, try to add the water. Try to imitate an earthquake. Maybe bang on your table, stomp on the floor, see if it's able to withstand some shaking. Or if you really want to get creative, blow on your tower and see if it can actually withstand that torsion, just like it would the wind. So go ahead, play with it and have some fun. Before we do our last activity, I want to talk to you about geodesic domes. Geodesic domes are a structure made up of a series of triangles that form a circle or a half circle when they're fully constructed. So we already have learned that triangles don't bend or cave in like a rectangle does. So as a building, a dome is really the safest and strongest, as well as the most energy efficient building design out there. You might recognize this picture. This is the Epcot Center in Disney World, and this is a great example of a geodesic dome. We're actually going to use our materials to build a geodesic dome next. All right, now we're gonna build our very own geodesic dome out of gumdrops and toothpicks. Out of your kit, you're gonna need 25 toothpicks, 11 of your gumdrops, and your paper plate. Go ahead and grab your materials so we can get started. Okay, now that we have all of our materials, let's get started on our geodesic dome. So to build our base, you're gonna need 5 of your gumdrops and 5 toothpicks. We're gonna put these in a shape that has 5 sides on each side. So I'm gonna take my toothpick and I'm gonna start connecting my gumdrops. So you're just gonna kind of build on these. It's gonna kind of have angles to it the same way that a triangle would. It's just instead of having 3 sides, this is going to have 5. And I'm gonna show you what mine looks like when I'm done so that you can see a good example. It might take some tweaking. Sometimes I'm not putting my toothpicks in at the right angle, so I just have to make some adjustments. Okay, perfect. You want it to be nice and sturdy. Make sure that your toothpicks are all the way in your gumdrops because we don't want them coming apart. And at the end, you should have a shape that looks like this. You should have 5 sides and 5 gumdrops. Okay, from here, we're going to start building our triangles on top of our base. So grab 2 more toothpicks. And in between 2 gumdrops, pick any 2 that are next to each other. You want to build like you would a triangle shape. So you want to stick a toothpick into each side, like this, and then take one of your extra gumdrops and connect it at the top, like this. So it should look like this. Have that triangle kind of sticking out at the side, and we're actually going to do that on all 5 sides of our base. And each of these triangles is going to connect, let's see, into its own gumdrop. So when this is done, you are going to have, let's see, we should be using all but one of our gumdrops when this is done. So just work your way around. I'll show you what mine looks like. When I'm done, I have one more side to go. Okay, so now I have my base, and on each side, I have a triangle built there around each of my 5 sides. So each of the 2 on a side of the base have its own triangle with another gumdrop there, okay? And then we're going to brace this even more. We're going to put a toothpick in between each of our top triangles. So just put one toothpick at the very top, kind of like this. So you're gonna have a 3rd triangle there in the middle, and that's just gonna brace it. And you wanna do this between every single triangle that you already built. So I'll show you the finished product so you can get a visual of what that looks like. This is going to make our structure really, really nice and sturdy because it's going to be completely made up of triangles at this point. The whole thing. No rectangles, all triangles. Okay, one more, and I can already tell my structure is really sturdy. Okay, so you kind of see that? So I have my base, I have my triangles on the side, and at the top I have this row of toothpicks that go in between each of my triangles. And then the last thing we're going to do is we want to put our last gumdrop on top, and we're going to use the last of our toothpicks to kind of brace it. So on the top of each of our gumdrops, you're going to put a toothpick. You're going to kind of angle it towards the very middle of your geodesic dome so that we can put our gumdrop right in the middle. So I'm actually going to put all my toothpicks in first, kind of pointing towards the middle, and I'm going to put in my gumdrop last. Okay. And then I'm going to connect my gumdrop to all 5 of my last toothpicks. And this is going to finish out my geodesic dome. Okay, so there we have it. It's kind of like a circle. The only place it's not like a circle is here at the bottom, which that makes sense because now we have a nice sturdy base. And this is by far the most sturdy structure that we have built so far. That thing's not going anywhere. No wind is going to move it. I can put a lot of force on there and it's not going anywhere. So I kind of wish I had used this practice maybe for my fuzzy tower. That might have been helpful. It doesn't quite have that height, but it definitely is very sturdy. So it probably could have then handled my water because mine did not. Okay guys, so this is the last shape that we were going to learn about. I hope you had a lot of fun today learning about engineering, learning about skyscrapers, and just learning a little bit more about how to build tall towers. So thanks guys, I'll see you next time.